Good morning friends. Today we are going to start a new chapter. That is Atoms chapter 12. Okay. Now, what is the atoms? Atoms is not seen by our naked eye. So the most of the physicists thought about that. What is the structure of the atom and also what is the shape and size of the atom, and atom is shown or how we can represent the atoms by the model. For that purpose, the different physicists represents approximate different 14 model of atoms. Out of these 14 models, the Rutherford's model and Neil Bohr suggested the two hypotheses in Rutherford's atomic model. So this model is fulfilled or completely represents the atomic model for the atoms. Okay, now, first, from the Thomson's experiment, Thomson proposed the first model that is known as the Plum pudding model. So, what is the Plum pudding models, and also what are the limitations of this model? So, the first question is that explain the Plum pudding model of an atom. So, Thomson's experiment shows that the atoms of the various elements contain the negatively charged electrons. So, Thomson performed the experiment and explained that the atoms of the various elements contain negatively charged electrons and they are identical for all atoms. So, Thomson suggested that in different elements, the atoms contain the negatively charged electron, and these electrons are same for all atoms. All atoms are electrically neutral, even though having the negative charge. He also suggested that all the electrons are electrically neutral, even though having the negative charge. Therefore, an atom must contain the some positive charge to neutralize the negative charge of the electron. So, Thomson suggested from the experiment that in spite of the electron possesses the negative charge, this electron behave as a neutral. So, the atom must contain the some positive charge to neutralize the negative charge of the electron. For this, the Thomson understood the atomic model that is known as Plum pudding model. Right. So, Thomson from the experiment suggested that all the atoms of several elements or the various elements contain the negatively charged electron. In spite of the electron possesses the negative charge, the electrons are electrically neutral. It means the atom must contain the some positive charge to neutralize the negative charge of the electron. For this concept, the Thomson understood this atomic model, and that is known as the Plum pudding model of the atoms. Now, according to this model, the positive charge of the atom is uniformly distributed throughout the volume of the atom. So, according to this Plum pudding model, the positive charge of the atom is uniformly distributed throughout the volume of the atom. Now, in this model, the negatively charged electrons are embedded in it like seed in a watermelon, and this is called the Plum pudding model of the atom. So here, the Thomson suggested that the positively charged is distributed throughout the volume of the atom, while the negatively charged electrons are embedded in it like a seed of a watermelon. So it means inside the atom, the positive and negative charges are uniformly distributed over the volume of the atom. That is the Plum pudding model. Again, our question is that explain Plum pudding model of an atom. So Thomson's experiment shows that the atoms of the various elements contain the negatively charged electron and they are identical for all the atoms. And also, all atoms are electrically neutral, even though having the negative charge. Therefore, an atom must contain some positive charge to neutralize the negative charge of the electron. For this model, or for this purpose, the Thomson introduced an atomic model that is known as the Plum pudding model. In this model, the positive charge of the atom is uniformly distributed throughout the volume of the atom, while the negatively charged electrons are embedded in it like the seed in a watermelon. So that is known as the Plum pudding model of the atom. Now, next question is that state limitation of Plum pudding model of the atom. What are the limitations? Why this model is failed to explain some properties of the atoms. So here first thing is that in Plum pudding model, the positive charges are uniformly distributed over the volume of the atom, while the position of the electron are fixed like as the seeds in a watermelon. It means the positive and negative both charges are uniformly distributed over the volume of the atom. One positive, negative, this way in entire volume the charges are distributed. So according to the law of electrostatic, the stationary charge distribution is not possible. So electrostatic law suggested that the stationary charge distribution is not possible because the electron of atom experiences the Coulomb's force due to the positive charge in atom. According to our model, electron and positive charge are uniformly distributed, while the law of electrostatics suggested that this distribution is not possible because the electron of atom experience the Coulomb force due to the positive charge in atom. So they cannot remain stable or the stationary but move with the acceleration. So here the charges cannot remain stationary under the Coulombian force act between them. And due to that reason, the stationary or the stable position of the charges is not possible, but these charges are moving with the some acceleration due to the Coulombian force. Hence, the distribution of the electron and positive charge are very different than the proposed in the model. So there is the first limitation of Plum pudding model. Again, the law of electrostatics, the stationary charge distribution is not possible because the electron of atom experience the Coulomb force due to the positive charge. So this electron and positive charge can't remain stable but move with the some acceleration. Hence, the distribution of the electron and positive charge are very different than proposed in model. So there is the first limitation. Now the second limitation is that each condensed matter at all temperature emits the electromagnetic radiation, in which continuous distribution of the several wavelengths is present, although their intensity is different. Now listen, while in condensed matter, at all temperatures, it emits the electromagnetic radiation, in which the continuous distribution of several wavelengths are present in this radiation, although their intensity are different. So that also not compare or not stable with the suggested Plum pudding model. Again, in condensed matter, at all temperature, it emits the electromagnetic radiation, in which continuous distribution of the several wavelengths is present, although their intensity is different. If the electron and positive charge are uniformly distributed, so here the continuous distribution of the wavelength take place in electromagnetic radiation and its intensity are also same. But here the intensity are different. Okay. Now second, next is in contrast light emitted from the ray gases heated in a flame has only certain discrete wavelength. The spectrum appears as a series of bright lights. The average spacing between atoms is large, hence radiation emitted can be considered due to the atom rather than because of the interaction between atoms of the molecules. So here, in contrast light emitted from the ray gases heated in a flame, only the certain discrete wavelength are obtained. The spectrum appears as a series of the bright lines. The average spacing between the atoms is large. Here in Plum pudding model, the average distance between the average spacing between the atoms is very large. Hence, the radiation emitted can be considered due to the several atoms, not due to the interaction between the molecule or the atom. But inside the atoms here, the interaction between the electron and positive charges also take place. Therefore, the radiation or once we obtain the light due to the emission by the ray gases, here the continuous or the discrete wavelength are obtained, not the continuous. So it shows that so radiation emitted can be considered due to the atoms then because of interaction between the atoms of the molecule. Clear? Now the next question, from which experiment Rutherford get the idea to propose the nuclear model? Again the question is that from which experiment Rutherford proposed the nuclear model? Okay, during the experiment of the alpha particle emitted by the some radioactive element and explanation of results, Rutherford gave an explanation of nuclear model. Again, our question is that from which experiment the Rutherford proposed the nuclear model? During experiment of the alpha particle emitted by some radioactive elements and explanation of the result, the Rutherford gave an explanation of atomic model. According to this, the entire positive charge and most of the mass of the atom is concentrated in small volume, and this small volume is known as the nucleus. That is known as nucleus, with the electron revolving around the nucleus in a circular orbit. When the Rutherford performing the experiment of the alpha particle emitted by the radioactive elements and explanation of the result of this experiment, the Rutherford gave the explanation of the atomic model. According to this explanation, he suggested that the entire positive charge of atom and most of the mass of the atom is concentrated in small volume. That is known as the nucleus. Or this small volume is known as the nucleus, with electron revolve around the nucleus. So according to the Rutherford suggestion, this small volume that is known as the nucleus. In this nucleus, the entire positive charge of the atom and the most of the mass of the atom is concentrated, while the electrons are revolved around the nucleus. Same as the planet revolve around the sun. How all the planets revolve around the sun in circular orbit. The same way the electron revolve around the nucleus. In this nucleus, the entire positive charge and most of the mass of the atoms is concentrated, which is also known as the planetary model of atoms and Rutherford's nuclear model. Again, during the experiment of the alpha particle scattered by some radioactive element and explanation of results, Rutherford suggested the atomic model. During this explanation, the entire positive charge and most of the mass of the atom is concentrated in small volume. This small volume is known as nucleus, with the electron revolve around the nucleus, just as the planet revolve around the sun. So this atomic model or the nuclear model is also known as planetary model of atoms, or that is also known as Rutherford nuclear model. However, this model could not explain why the atoms emit the light of only discrete wavelength. This model suggested by the Rutherford is not fulfilled or not complete. So it cannot explain why the atoms emit the light of only discrete wavelength. So for example, the hydrogen consisting of the single electron and single proton, why it emits a complex spectrum of the specific wavelength? In hydrogen atom, the single proton and single electron are present. In spite of the single electron and single proton, why it emits a complex spectrum of the specific wavelength? That cannot be explained by the Rutherford's atomic model. Again, which experiment the Rutherford get the idea for atomic model? During the experiment of the alpha particle scattered by some radioactive elements and explanation of results, Rutherford also explained the atomic model. According to the explanation of the Rutherford, entire mass of the atom and all positive charge is concentrated in small volume. This small volume is known as the nucleus, with the electron revolve around the nucleus, like as the planet revolve around the sun. Due to this reason, this model is known as the planetary model or Rutherford's nuclear model. This model cannot explain why the atoms emit the light of the discrete wavelength. For example, the hydrogen consisting the single proton and single electron, why it emits a complex spectrum of the specific wavelength. Clear? So that is the basic concept about the Rutherford get the idea about the atomic model. After that, the describe the Geiger-Marsden's experiment or the scattering experiment. What is the Geiger-Marsden's scattering experiment? So here the figure, there is the source of alpha particle, here there is the gold foil. When the beam of the alpha particle is incident on a gold foil, so alpha particle is scattered in different directions. So here the circular screen is present. So what are the alpha particles are scattered at a particular angle. After the scattering at particular angle, when it strikes with the screen, here the places where the scintillation is produced. According to the counting of the scintillation in particular direction, we can judge about that how many numbers of the alpha particle are scattered at particular angle. So there is the Geiger Mustang experiment. Again, it's shown in the figure, source of alpha particle, here the gold foil. The source of alpha particle produces the beam of alpha particle. Here, what are the alpha particles are emitted by the source must passes through the lead bricks. So as a result, a narrow beam of the alpha particle is obtained, and this narrow beam of alpha particle is fall on a gold foil. And then these alpha particles are scattered in different scattering angles. As shown in the figure, a beam of alpha particle of 5.5 MeV energy emitted from bismuth 83-214, where collimated into a narrow beam, collimated by a narrow beam by passing through a lead bricks. This beam was allowed to fall on a thin foil of gold of thickness 2.1 into 10⁻⁻⁷ meter. The scattered alpha particle on striking the screen produced the bright light flashes, that means the scintillation. Again, describe the Geiger Mustang experiment. Here the figure, source of alpha particle. So here the alpha particle are emitted by the source. Source is actually, there is the bismuth 83-214 radioactive element which produce the alpha particle. This emitted alpha particle, after passing through a lead bricks, it converts into the narrow beam. This narrow beam is incident on a gold foil. After the incident on a gold foil, the different alpha particles are scattered in different directions. When this scattered alpha particle striking with the screen, it produces a bright light flashes, that means the scintillation. Later, there is a explanation of the Geiger Mustang scattering experiment. And also, now there is a schematically diagram. There is the source of alpha particle. What are the alpha particles are emitted by the source? There is the bismuth 83-214. So this alpha particle must pass through the lead bricks. So as a result, the narrow beam of alpha particle take place. There is fall on a thin foil of gold. That this line is the thin film of a gold. So what's happened? After the incidence on a thin film, so here the some alpha particles are scattered or traveling in this direction. They are scattered at the small angle, while the some alpha particles are obtained in this direction. These alpha particles are scattered at large angle of scattering, and some angle are scattered in back direction. After the incidence, they are scattered in this direction. So due to that result, here the circular screen is placed, and also the microscope is also placed, and this microscope is movable at 360-degree angle. So we can judge about that how many numbers of the alpha particles scattered at the small angle, and also at large angle of scattering, and some alpha particles are scattered in that direction. These places are observed through a microscope, and the distribution of number of scattered particles may be studied as a function of angle of scattering. And then we can do the graph of number of alpha particles scattered at different scattering angle. That means we do the graph of number of the alpha particles scattered and versus the angle of scattering. Again, describe the Geiger Mustang scattering experiment. Here the both figure are given. There is the experimental figure, there is the schematic diagram. Okay. Now here, bismuth is the source of alpha particle. But the alpha particle emitted by the bismuth having the energy is 5.5 MeV energy. This scattered alpha particle passing through the lead wings to produce a nerve beam of alpha particle. This nerve beam of alpha particles are scattered on a thin foil of a gold having the thickness is 2.1 into 10⁻⁻⁷ meter. After the stacking of the alpha particle on a gold foil, the different alpha particles are scattered in a different angle. Some of the alpha particles are scattered at small angle, while some at large angle of scattering, and some of alpha particles are scattered in back direction. So these scattered alpha particles strike with the screen and produces the bead-like flashes. That means the scintillation is produced. And also the arrangement of the microscope is done, and this microscope is movable at 360 degrees. So it can collect the scattered alpha particle at the different scattering angle. Clear is? Okay. These flashes observed by a microscope, and the distribution of the number of scattered particles may be studied. And then we do the graph of scattering alpha particle versus the scattering angle. Clear this? There is the description of the Geiger Marsden's experiment.